Hello guys, today we're going to talk about the plant watering notification system. This is a simple home automation project using Mulesoft and Raspberry Pi. Um, this the scope of this is to alert whenever there is a need for water in the plant jar. Um, we can achieve this using a Raspberry Pi and a Mulesoft and a moisture sensor. So let's look at the parts. What we need for this, we need a Raspberry Pi 4 or a 3. I currently have 4. And we need a I2C capacitive moisture sensor and some breadboard jumper wires. So let's look at the softwares, what we need in here. So we need a Raspberry Pi and Raspbian OS, which is available free on the Raspberry Pi website. And there is a Mule Enterprise Edition standalone server. There is a trial available, the trial license available for 30 days, free for when we register your account, and a Postman obviously to send a request, and Twilio uh, to enable SMS component. And obviously we need a computer to do the programming for both MuleSoft and uh, Raspberry Pi.
Okay, here are the three hardware parts I used for this project. One is a Raspberry Pi 4. I have this, I bought this on eBay, and this is a moisture sensor. This is a capacitive sensor. There are also resistive sensors available, but this works better when it comes to sensing moisture. And these are some breadboard wires. These are female to female, so which I use to connect my sensor to the pins in here.
This is the official website of the moisture sensor, which we bought. It's learn.adafruit.com. So this is where we can get what are the pins which we need to connect to the Raspberry Pi 4. So this is a link I will be providing on the video description. So if you look at this, as I showed you earlier, so the red wire goes to the first pin, and the black wire goes to the ground. The white wire goes to the pin 2. This is actually 3, and the green wire goes to the pin 5. So how do you know what each pin identifies? So there is another link which you can use to see what each pin identifies. So if you look at here, so this is how the pin structure is identified. So this is 1, 2, 3, 4, 5, 6. This is how it works. So the first pin is DC power, the red wire which we attached, and the second one is GPIO pin, and the third one is GPIO2. The third one is GPIO2, and the fifth one is GPIO3. And this is where we connected our white wire and green wire, and finally the ground wire goes to the 9.
So look at this. I have turned on my Raspberry Pi, connected this to the power cable, and if you look at this, there will be a red light indicating that it is turned on and active. Now we can log in to the Raspberry Pi and see how it goes. Okay, so this is the official Raspberry Pi website. So this has information on how to download your Raspbian OS and burn the image to the Raspberry Pi. So for my use case, I have to download the image for Mac OS and burn the image. So this is where in the documentation link where we have how you actually set up your Raspberry Pi and connect to your display, or you can use command line. I mean, there are very interesting things where what you can do here. I mean, depending on your requirement. What I have done is install Raspberry OS, and instead of a display, I have been using the command line just like any other Unix system.
All right, so I was able to install my Raspberry Pi and I was able to connect. Let's see how to do that. So here is my terminal. So what I'm going to do is log into my Raspberry Pi using an SSH. So now I am in my Raspberry Pi OS, logged in as Pi user. If you look at this, this is my uh, Raspberry Pi home directory, and I can also use a VNC server to connect it using a display mode. Like, now this is how I connect. So you can basically use this endpoint, connect to it, click continue. So this is how the display looks like. Close this. This is my home directory. So instead of using a display, I'll be proceeding with the command line because I feel more comfortable with the command line than display. So what I'm going to do now is the next thing what we need to do is download Mulesoft. So this is the link. I will provide it in the description. This is the link where you need to register yourself as a trial user, and that will allow you to download a 30-day free trial. So I have done that already and then downloaded this, which is in my directory. So I'm going to push this to my Pi using SFTP. So let's do that. Okay, now I'm connected. I'm gonna go to my mule directory, which I've created in Raspberry Pi, and push this particular jar or zip file into the Raspberry Pi. Yep, it's being uploaded to the Raspberry Pi. All right, looks like it has been uploaded 100%, so which means we have the file. So, which is good. I'm gonna log in back to my Raspberry Pi using SSH and look at if the file is available. Yes, I do have the file. So now let's go ahead and install it. All right, now let's unzip this, whatever we have transported. This will unzip the Mule application server 4.4 Enterprise Edition. Okay, so this has been successfully unzipped. Now, if you look at this, this will have the application structure of it. However, we need to still install a Tanuki wrapper, which is a Java service wrapper, to start this on the Raspberry Pi as a service. So to do that, we need to do some additional steps. The first one is download the wrapper from the Tanuki official website. You can do this by this command. I'm gonna put this in the description. So this will download the Tanuki wrapper, and we need to move some of the wrapper files into this Mule Enterprise Edition application server. We need to unzip that. All right. Okay, now this is going to work. All right, now this looks good. Let me go ahead and start the server and see if it's starting fine. Okay, it is launching the service using the Java service wrapper, which is the Tanuki wrapper. Alright, looks like server has been successfully started. We have the Mule server running successfully. We need to build our Mulesoft application to enable integration between the sensor and SMS system. So for an SMS system, I used Twilio, which is an out-of-box connector available in MuleSoft for sending SMSs. So it is available free for a trial account of $13 or $14. So we do not pay anything until $13. So this is how we can create an account in Twilio. So go to the twilio.com and you can register yourself here, and by clicking on sign up for free, provide your information, uh, and it will create an account for you. And this is my account which I've created, and it will give you a free US toll-free number, and it will give you an account ID, auth token, and your phone number. This is what you will use to connect to Twilio and send an MS to you. So if you look at this, this is the worth of your trial account. You can still upgrade if you want to, but it costs you money. Right now, what I have is a free account. So let's go to the MuleSoft code. Uh, so this is what it does. I've been using a simple HTTP request. So it receives a request to check the water level, and there is a Python. What I'm doing is I'm executing a Python script, and this Python script is available in the Adafruit, which is the sensor which we bought. This is what I used. I tweaked this code a little just to not to run in loop because we are doing an on-demand request. So this uses this particular script to read the pins, you know, uh, from the Raspberry Pi, as I've shown you earlier, and gets you the temperature and moisture. Uh, and this is what we are going to use. This is the parameter which we are going to use to determine uh, the level of water in our soil and send a message accordingly. So let's go back to the code. What I have, this is what it is. So same code, just I tweaked a little to use the pins. And instead of loop, just I'm reading it once and leaving it because it's an ad hoc request for me. And that is the Python script which is get executing using Groovy engine, and it gets me a result. And from there, I'm going to transform it as I need it, pick the moisture value, and generate a percentage of it. And from there, I am going to uh, send a message to my mobile using the Twilio connector.
Alright, now that we have everything ready, let's look at how we can test this. So this is a plant I have which I am going to use to test it. This is my Raspberry Pi, and I have inserted this in the soil. If you look at this, it's almost 70% inserted. So let's look at now. Let me post a request and see what happens.
All right, now my application is successfully running. Latest code which I have. So if you look at the process, it looks like it's running successfully. So what we're going to do now is basically post a request to my uh, to my service, which is running on the Raspberry Pi, and see what happens. Simultaneously, I'll be monitoring my mobile. Let's go to the postman. This is my host, and this is my port running on the Raspberry Pi connected over Wi-Fi. And this is my water level which is the resource which is listening to the request. Let me quickly post a request. All right, successful. Send to Twilio trial account, message from plant water notification. Recorded is 58. Attention, soil water is low. Please water your plants. Let me see if I have the message. Okay, I do have the message on my mobile. Same text.
Now I'm going to put water in the soil and wait for it some time to settle and repost a request and see what happens. I have let it wait for some time. Now I'm going to repost the request and see what happens. Okay, same resource. Let me try to repost the request. Okay, see, looks like it's working. So now it has crossed the 80%, which is the set mark I set, and soil water is good. Watering is not needed. Let me look at my mobile. Yes, I have the same message on my mobile.
All right, so there are other enhancements we can do to this, like connecting to other IoT device or sending message over Slack or WhatsApp. All these are possible. You can try that, and thank you.